Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on equivalent fractions. So two fractions are said to be equivalent if they have the same value. For example, you would know even before this video something like 4 over 8 and 12 over 24 are equivalent fractions. They are equal in value. They both equal 0.5. If I were to offer you 4/8 of a pizza, that's exactly the same as offering you 12/24 of a pizza. So that's what we mean by equivalent fractions. So more generally, if you have two fractions, I'll call one of them A over B and one of them C over D, they are equal. They are equivalent and have the same value if AD is equal to BC. So this is a bit of a complicated way to think of it. What it essentially says is that two equations will be equivalent if you do the same to the top as you do to the bottom. If you multiply the top number, the numerator, by the same number that you multiply or divide the bottom. So if we look at our examples up here, to go from 4 to 12, I've times the numerator, the top number, by 3. But I've also times the denominator by 3. I've times top and bottom by the same number, and that's why the fractions are equivalent. So let's say I start with a fraction like 50 over 70. So any fraction I make will be equivalent to this as long as I do the same to the top and bottom, times or divide by the same number. So I could divide the top and bottom by 2, for example. As long as what I do to the top, the numerator, I also do to the bottom, they'll be equivalent fractions. So 50 over 70, that gives me 25 over 35. These two fractions are equivalent. They both have the same value, which is like 0.714. So if I take this fraction, I can find another equivalent fraction if I do the same to the top and the bottom. I could say times top and bottom by 4. Then I would get 100 over 140. These two fractions, this one and this one, will be equivalent. And of course, this means that this fraction and this fraction will also be equivalent. If I don't do the same thing to the top and the bottom, the fractions will not be equivalent. So for example, let's say I have the fraction 15 over 19. So let's say I times the top number by 2, but times the bottom number by 3. Well, 15 times 2 is 30, 19 times 3 is 57. So these two fractions are not equivalent. They do not have the same value. So 15 over 19 is about 0.79. This fraction here is about 0.53. So these two fractions are not equivalent because I times the top by 2, but I didn't do the same to the bottom. So equivalent fractions are important for a number of reasons. One that you would be familiar with is simplifying. So to simplify a fraction actually means you're finding an equivalent fraction, but one with lowest possible whole numbers. So if I start with a fraction like 12 over 30, I can divide top and bottom by 2, and I will get an equivalent fraction. So I'll get 6 over 15. Now both of these have the same value, both equal to 0.4. They're equivalent because what I did to the top, I did to the bottom. So this fraction here is simpler than this fraction here. They both have the same value, but this has lower whole numbers in it. 6 instead of 12, 15 instead of 30. So if you want to simplify a fraction completely, what you need to do is divide top and bottom by the highest common factor. Remember, the rule is what you do to the top, you must do to the bottom. So if I want to simplify 6 over 15, the highest number that goes into both is 3. So I need to divide the top by 3 and the bottom by 3. So 6 divided by 3 is 2, 15 divided by 3 is 5. So these two fractions, they're all equivalent, all equal to 0.4, but this one's said to be simpler because it has lower whole numbers. So let's say I was asked to simplify 36 over 45. I want to find an equivalent fraction with lower whole numbers. The highest number that goes into 36 and 45 is 9. So I'm going to divide the top by 9. What I do to the top, I must do to the bottom. So 36 divided by 9 is 4. 45 divided by 9 is 5. These two fractions both equal 0.8. This one's simpler because it has lower whole numbers. So equivalent fractions can also be used to compare fractions. That means tell which fraction is larger. So let's have a look at that. So let's look at this question here. Let's say Thomas kicked 11 goals from 12 attempts this year. Daniel has kicked 14 from 16 attempts. Who is the more accurate kicker? So we're actually going to use equivalent fractions to help us here. See, Tom, he's kicked 11 out of 12, and Daniel has kicked 14 out of 16. So to find out who's more accurate, we want to know who has kicked a larger fraction of their attempts, who's been successful in a larger fraction of attempts. So these two fractions are hard to compare. It's hard to tell which fraction is larger because they don't have the same denominator. What we can do is we can find an equivalent fraction for this and one for this that have the same denominator. Then they'll be easier to compare. So what I want to do is I want to find a number that is divisible by both 12 and 16. So if I don't know that, I can just go up by multiples of 16. So 16 is not divisible by 12, neither is 32, but 48 is. 48 is divisible by both 16 and 12. If I times this denominator by 3, it will become 48. So I want the fractions to be equivalent. So if I times the bottom by 3, I need to times the top by 3. Now for Tom's fraction, I want to times 12 by 4 to get to 48. So if I times the bottom by 4, I must times the top by 4. So Tom has kicked 11/12ths of his goals, which is the same as 44/48ths of his goals. Daniel has kicked 14 times 3 is 42, 16 times 3, 48. So Daniel's kicked 42/48ths of his goals. So we see that the fraction of successful attempts is more for Tom than Daniel. This fraction is bigger than this fraction. So we've just learned 11 over 12 is greater than 14 over 16. Remember, crocodile eats the larger number. The greater than symbol points to the right. So therefore we can say that Tom is the more accurate kicker. So let's try this question here. Which fraction is halfway between 1/9 and 1/11? So a lot of people looking at that would say, okay, clearly it's a tenth. Well, it's actually not. 1/10 is actually closer to 1/11 than 1/9. How are we going to figure this out? Well, what we're going to do is we're going to use equivalent fractions. So 1/9, I can times the top and bottom by the denominator of the other fraction, 11. 1/9 is the same as 11 over 99. 1/11, I'm going to times top and bottom by the denominator of the other fraction. 1/11 is the same as 9 over 99. So this is equal to 1/9, this is equal to 1/11, so halfway between them is of course 10 over 99. And you see this was all done using equivalent fractions. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.